We are going to solve an actual problem, an SAT problem, which at first glance will have most students just run screaming from the room. But I'm going to show you that this is still something that is made up of multiple simple steps, and when each one of the steps is understood, this entire problem becomes simple. Again, each one of these steps requires a background, so if any one of these steps doesn't make sense, it's because you're missing that background, and we can fill that. But for those who will actually understand, who actually already have that background, and still can't solve this problem, this should show you how to solve this problem. So here is the problem. Don't freak out. This is not a polynomial. This is an equation. This is an equation of a single variable. We have a single variable x, and we have this messy fraction. This is a rational equation. The reason it's called a rational equation is because you have x in the denominator. So this is not a polynomial. A polynomial cannot have x in the denominator. But this is an equation, and what it means is this equal sign means that this expression on the left, has the same value as this expression, which means this whole thing resolves to 1. And let's go through the steps of solving this, and it's a series of transformations. So the first thing we're going to do, so what are the steps necessary? The skills you have to have, the individual skills that are built up over the grades. This is a SAT problem, which basically is something that was probably covered in Algebra 2 in 11th grade. And it involves skills and knowledge that's built up from the first grade all the way through 7th and 8th grade, and 9th grade, 10th grade. And those skills are how to factor a polynomial. I've done a whole separate video on that, again, showing the high level, but what is a polynomial? How do I factor a polynomial? How to find the lowest common denominator. Now, this we learned in the 5th grade, but everyone forgot it. We learned how to do this with integers, but now we're going to have to do it with algebra and polynomials. But if you learn how to do this, if you know how to do this with an integer, which, by the way, nobody does know how to do, then it's easy to learn how to do this with algebra. But in order to do it with algebra, you have to first understand what it means to find the lowest common denominator. And that involves writing a polynomial as a prime factorization. That's another skill. Then you have to know how to eliminate fractions by multiplying. Once you find the lowest common denominator, how to get rid of fractions by multiplying by that LCD. Then you have to know how to multiply polynomials. You have to know how to divide polynomials, which means cancel out terms. You have to know how to combine like terms. Then you have to know how to manipulate the algebraic expression to set the polynomial to 0. I'm going to go through all these steps. Then finally, you have to know how to solve that quadratic equation using the quadratic formula. You have to know what the discriminant is, which is part of the quadratic formula. And finally, understand the discriminant, and that will, voila, give you the solution to this equation. Let's go through those steps. So this is what we start with. And everything in math, from first grade on, is transforming one form of an expression to an equivalent form of an expression. What's the first thing we're going to do? We're going to take this x squared minus 9, and we're going to take this x squared minus 9 and factor it out, because x plus 3 is already prime. X plus 3 cannot be factored. If you don't know what that means, we have to go back to 5th grade, 6th grade, 7th grade, 8th grade. But x plus 3 cannot be factored. It's in its prime or simplest form. X squared minus 9 can be factored. How do we factor it? X squared minus 9 can be turned into this. X plus 3 times x minus 3. This is a difference of perfect squares. X squared is a perfect square. 9 is a perfect square. Again, if you don't know what that means, that goes back to probably 9th grade, depending on when you learned it. Some advanced classes learn it in 7th grade, some in 8th, and some in 9th grade. But either way, if I'm talking to you in this problem, you would know how to turn x squared minus 9 to x plus 3 times x minus 3. Now that we did that, we can rewrite the original expression with its factored form. It's now 2 of x plus 3 plus, instead of x squared minus 9, we turn that to x minus 3 times x plus 3. So this is the same expression, but simply with this denominator factored. Now that we did that, we can now find the lowest common denominator. Now that we have this, the lowest common denominator is we have 3 denominators, and therefore, and once we factored it, the lowest common denominator is simply x minus 3 times x plus 3. Again, to understand this, you have to go back to 5th grade to how to find the lowest common denominator of integers. And then you have to go to algebra and learn how to do the same thing with algebra. So right now I'm going to tell you that the lowest common denominator of these 3 fractions is x minus 3 times x plus 3. Now that we have that lowest common denominator, we're going to multiply each one of these terms. There are 3 terms, this one, this big one, and the 1. The 1 is easy because 1 times x minus 3 times x plus 3 is simply x minus 3 times x plus 3. So this, I'm not going to even bother showing you how to do this because that's simply multiplying by 1. But I'm going to do these 2 in separate slides. What's 2 over x plus 3 times this lowest common denominator? Here it is. The lowest common denominator is x plus 3 times x minus 3 times 2 over x plus 3. Well, the x plus 3 cancels the x plus 3, and that leaves us just with x minus 3 times 2, which is 2x minus 6. So this whole first term becomes 2x minus 6. Let's go to the second term. The second term was this mess, negative 12. When you take that negative 12 and multiply over x minus 3 times x plus 3, both of these cancel, both of these, and you have just negative 12. So we've now converted this messy thing, these 2 terms, to simply 2x minus 6 minus 12 equals, and then 1 times x plus 3 times x minus 3. So we turn, by multiplying by the lowest common denominator, we get rid of the fractions. Now we're left with this. And now you have to be able to distribute again, multiply that out. So first combine like terms. Negative 6 minus 12 is negative 18. So you have 2x minus 18 equals. And then we can multiply this out. And you get 2x minus 18 equal x squared minus 9. And now we add 18 to both sides. And we set that, and we add and subtract 2x from both sides. So the 2x goes over here. The 18 goes over there. What you end up with is x squared minus 2x plus 9 equals 0. And that now is a quadratic equation, but it can't be factored easily. There's no integers to factor it, so we have to resort to the infamous quadratic formula with a, b, and c, a being 1, b being negative 2, and c being 9. And all we care about really is this, what's called the discriminant. This, under the square root, this b squared minus 4ac is the discriminant, because if that number is negative, then the square root of a negative number is not a real number. So this discriminant, so we're just going to compute that b squared minus 4ac. And since b is 2, it's negative 2 squared minus 4 times a, which is 1, times c, which is 9, is 4 minus 36, which is negative 32. And therefore, if you plug that into the quadratic equation, negative 32, square root of negative 32 is not a real number. And therefore, this quadratic equation has no real solutions, which means we started with this mess over here, and we turned it into a quadratic equation, solved that quadratic equation, and discovered that because the discriminant is negative, there are no real solutions. That is this single SAT problem. And now that you've done that on the SAT, you can actually solve this by just typing the original equation in, if you know how to do it, into the Desmos calculator, and the Desmos calculator will right away, instantaneously answer this question for you. And so on the SAT, that's how you actually are going to do it. But no, even to do that, you have to understand what this means, what this is. If any of this did not make sense, and I expect that from most people watching this, if you're unlucky enough to be watching this, Um, it looks like gobbledygook, but I know if you contact me, click the link below, join my community, contact me, I know I can show you how to turn this gobbledygook into something that makes sense. And once you understand this gobbledygook and understand what it means and understand how to solve this, you will have fun doing an equation like this, because it literally becomes fun. You're starting from a point where this makes no sense. And when you just learn how to make sense out of this, it actually becomes fun.